it start peaking really?
Plane curves, parametric equations. This really isn't going to mean much to you right now. I'm just going to kind of show you how to do the problems. We're going to cut this into 2 days, this section into 2 days. On Wednesday we'll do a review and Thursday will be the test. So there's only 4 sections in this chapter. But plane curves, basically what we're going to talk about is there's 3 different variables. We're going to start getting into 3 dimensions eventually. And really what we're going to talk about today is the third variable being time, t, and what happens over the course of time to x and y. So let's just kind of get into this. I'll show you the basic part of this. We'll do number 4 to start. X equals 6t minus 4 and y equals 3t. So here, one of the parameters, they said t has to be greater than or equal to 0. So what you're going to do is you're going to make an xy chart because you really don't know exactly what to do here. For time t, as t increases from 0, time starts, what happens to x and y? And all you're doing is plugging in values. And then we're going to graph it. And then we're going to do something else. And that's the little complex part that we need to learn. This part's the easy part. You're going to do this on every problem tonight. We're going to start at 0 for this problem. If I plug 0 into the x equation, what is 6 times 0? Minus 4, negative 4. So x is negative 4 when t is 0. What is y when t is 0? 0. Okay, so negative 4 is 0. On my rectangular coordinate system, that's where I'm at. That's where I'm starting. I'm not going any further left than this because of the parameter there here. All right, so let's just plug these in. Everybody do these next 3. Plug them in and plot them and show me what you get. This is part A. Slow down. Going too fast. Good. Good. Participate. All right.
I couldn't find my pencil.
Oh, I know. It's tough. Coming to math class, not sure where your pencil's at. That's a bad thing. Looking good. Everybody can graph. Amazing. All right. So I'll go through this with you while you're finishing up. When t is 1, I get 6. Minus 4 is 2. And 3 times 1 is 3. So there's 2, 3. And 2, that's 12 minus 4 is 8. And 3 times 2 is 6, so 8, 6. And again, this is not an accurate graph, but as you can tell, this makes a straight line. And 18 minus 4 is 12. 3 times 3 is 9. And that goes on up there, whatever. That's what it looks like. Straight line. If you plot those points on an accurate graph, that's what you're going to get. Now, that's really what you're doing all of today. Half your assignment will be this easy. The other half we're going to deal with trig functions, which we're going to use the unit circle. And the unit circle should be easy for you by now. We're not doing anything really difficult. We're not going crazy. It's the part B that we really need to focus on. Part B for this stuff will be as easy as well. I need to know the equation of this line by using this information. And I need to get rid of t. Okay, so I'm going to eliminate this parameter t out of here. So how do I do that? To eliminate a variable, I solve for t and plug that information into the other equation for t. And that way your t is gone. So I'm going to just go ahead and I'll pick this equation, I'll solve for t. So how do I get t by itself? Divide by 3. So t equals y over 3. So now I'm going to put y over 3 into this equation for t. So x equals 6 times t, which is y over 3, minus 4. And everybody solve that equation. and then solve for y. Get y by itself. Put it in, or let's just leave it like that. Go ahead and simplify, and then get y by itself. And then I'll review what it is you're doing. We'll do some harder problems. Yeah, 2y minus 4. And 4 and 5. Excellent. Get y by itself. Solve for what? So that'll be 6 times y divided by 3. So 6y over 3. What's the 6 over 3 do? 2y minus 4. 6 over 3 is 2. Yeah, add 4, you get no. That 4 doesn't have an x with it, so it's x plus 4. Alright, let's take a look. This is how you should have solved it. 6 over 3 is 2, so that's 2y minus 4. Add 4. The 4 doesn't have an x, so you can't put them together. Divide by 2, that's 1/2 x plus 2 equals y. That's slope-intercept form. This is a straight line, so anytime you have a straight line, you could probably solve this and get it in, well, you could solve it and put it in slope-intercept form. This is the equation of that line. I already told you that's what it was. That's kind of what part B is. You're going to be given this, this setup, these equations, and you're going to plot them, and they're going to make curves. They're going to make hyperbolas. They're going to make an ellipse. I almost said eclipse. They're going to make an ellipse, a circle, straight lines. So yes, I did say hyperbola, and I'm also absolute value stuff. I'm not sure which ones are in the even problems, but I didn't give you any even problems. But you're going to plot all these points, and you'll start to recognize what it is that you're drawing. And then part B is to actually come up with the equation of what you have. So let's do a harder one that deals with some trig functions to show you this. Not really difficult. Wait a minute. Step 1. You're going to have a t and an xy chart. You're going to plug in values. And you're going to plot those values. That's step 1. Step 2, you have to figure out a way, which in this case, solve one of the equations for t, substitute it in the other equation. This is good enough. I just wanted you to see that this is the equation of this line. So I just had you solve for y. You don't have to solve for y. Once you get it like this, you can stop. So that's part B. Now let's look at the more difficult stuff. Let's do... I'll do number 14 and 16 in the other class. We'll do this one. X equals 2 cosine of t. Y equals 3 sine of t. And t is between 0 and 2 pi. Okay, so we're not going to go into negatives. We're not going to go backwards on the unit circle. We'll just do all positives from 0 to 2 pi. Okay, so I'm going to, again, part A. I'm going to make a t, x, y chart so that I can graph this. Start at 0. And then, so you notice the t is in the degree position, so we're talking about our degrees that we've been dealing with. So I'll do a pi over 6, pi over 4, pi over 3, pi over 2. And let's just stop there and see what we get. So let me do a couple of these with you, and then I'll have you try to work through one of them, okay? So t is 0, meaning the degree is 0. What is the x value at 0 degrees? 1. So 2 times 1 is 2. What is the y value at 0? 0 times 3 is 0. So 2, 0 is my first coordinate. I don't know how big my graph's got to be, so I'm just going to draw this. All right, now let's do 30 degrees. Some of the problems, they'll put the sine here and the cosine there, and you'll be sitting there going, wait, the sine is the y value, I'm solving for x. This doesn't make any sense. Just disregard this until you finish the problem. So what is the x value at 30 degrees?
30.
Okay, radical 3 over 2 times 2. Right? Radical 3 over 2 times 2. That's radical 3, which is 1.7. So you're going to want to write some decimal stuff down on your paper because you're going to get lots of weird answers. You got to be able to graph this stuff, okay? And then what is the y value at 30? And what is 1/2 times 3? 3 over 2 or 1.5. So now we're at 1.7, which is about right there, and 1.5. About right there. Okay. What about pi over 4? The next value of pi over 4? Radical 2. Everybody split these out. Radical 2 over 2 times 2. And what is the square root of 2? Oh wait, figure it out. You gotta know what they are, you gotta be able to graph this. Your calculators, square root of 2.
It's like 1.4 or something.
1.4? Good enough. What's the y value? Radical 2 over 2 times 3. That's 3 radical 2 over 2. Somebody tell me what that value is. 3 times radical 2. Divided by 2? 2.1? You guys check, make sure you're right. 1.4 is about right there. And 2.1. Crazy. Pi over 3 is 60 degrees. What's the x value of 60? Times 2. 1/2 times 2. What's the y value of 60? Radical 3 over 2 times 3. So what's that on your calculator? 2.6. Look what's happening. Your x value is decreasing, your y value is increasing. So here's 3, 2.6 is about right there. I'm going to accurate graph a little better. All right, now about 90 degrees. X value of 90. 0 times 2 is 0. Y value of 90. 3 times 1 is 3. 0, 3. Look at that. Hopefully you see some symmetry and you can cut corners. If there is symmetry, you can start to go a little bit faster. Other than that, you're going to have to do a few things. Let's keep going. Let's see if there's symmetry here. If this is a 60 degree reference, what's this angle here? We're going to match it. What's the 60 degree reference angle here? What is this one? 120, which is 2 pi over 3. Let's see if that's symmetrical. It's a 60 degree reference, but you're in the second quadrant. What is the x value at 2 pi over 3? Negative 1/2 times 2 is negative 1. Okay, so it's starting to look good so far. Now, what is the y value at 60 degrees? And that's positive in the second quadrant, times 3. So 3 radical 3 over 2, it's the same thing, so 2.6. It is symmetrical at this point. Let's just make sure, let's see if at 2 we're at 0, this will be pi, right? X value of pi? Negative 1 times 2 is negative 2, which is, we're hoping it's going to be 0 here. Y value of pi? 0 times 3 is 0. Alright, so I don't have to figure out all of those others. So start using your brain. Do not ever assume that it's going to be symmetrical. You need to plug in a value to make sure. Don't assume that this is going to keep going around. It might. Don't assume. Some of the problems do not. So you need to plug in a value to make sure. I'm going to go ahead, instead of plugging in these, I'm just going to see if I get, what do I get for, what is this one? What degree? 3 pi over 2. So what's the x value at 3 pi over 2? At 270? 0. What's the y value at 270? Negative 1 times 3 is negative 3. So it does come down. And you can check this. It's going to work. That's an ellipse. Great. Not too bad, right? It does take a little bit of time. Now, the hard part. Part B. Everybody get out your reference sheet and look at your Pythagorean identities. You're going to use these on the trig stuff. Find Pythagorean identities down there. It's not that you're just going to use these. You might use a double angle formula too. You got to be able to recognize these so you can quickly look at your reference sheet and use them. It is not possible for me to show you every single problem. You're going to have to look at this and go, okay, what of my Pythagorean identities can I use? If I have cosine and sine, what would be wonderful? What Pythagorean identity deals with sine and cosine? This should be like rattling it off. You should be able to rattle this off just like you rattle the Pythagorean theorem off. With sine and cosine, what do you have? Sine squared plus cosine squared equals 1. Out of any of those identities, that one should be rattled off just like your Pythagorean theorem. You should know that forever. Okay? So, what I have here is I want to use these two equations and add them together, multiply them somehow in a way that t disappears, just like what we did right here. Okay? So, if I wanted this to be cosine squared and that to be a sine squared, what would I have to do? Can I just make that cosine squared? I can if I follow the rules of math. What do I get if I square? I don't want to say it. Let's get cosine by itself first. How do you want to do that? How do we get rid of this 2? Divide. Okay, so let's just look at this. So here we have x over 2 equals the cosine of t. Let's get y by sine by itself. What do? Divide by 3. All right, so now I have y over 3 equals the sine of t. All right, if I wanted to square this, can I just square the right side? What do I have to do? Square both sides. So here I have x squared over 4 equals cosine squared of t. Same thing. I square both sides. I can do anything I want, provided I follow the rules. What about here? Equals the sine squared of t. If I add the two equations together, have you ever done that before? Adding equations together, maybe to eliminate things? You can't do that, right? Alright, so if I put these two equations together, I get x squared over 4 plus y squared over 9 equals the cosine squared of t plus the sine squared of t. I added the two equations together. What is this? 1. X squared over 4 plus y squared over 9 equals 1. What is this? Equation of an ellipse. Center at 0, 0. The x-axis is at plus or minus 2. The y-axis is plus or minus 3. Algebra 2. Let's do another one before we're done. That's the answer. That's the equation of that line. That circle. Ellipse. Alright, let's do another difficult one, okay? How about 22? X equals the secant of t, y equals the tangent squared of t. Part B, real quickly. What do you think you're going to use? What? In your Pythagorean identities.
Tangent squared x plus 1 equals...
Yeah, tangent squared plus 1 equals the secant squared. That's what you should be thinking of as soon as you see that. Let's start with doing our charts. We're just going to do a couple and then we're going to move on to do part B because I want you to see part B. This stuff you should be able to do. This is between 0 and pi over 2. So we're only going in the first quadrant of our polar information. So 0, when secant is 1 over cosine, right? And tangent is sine over cosine. So let me draw the Pythagorean theorem, or unit circle here. So at 0 degrees, the secant is 1 over cosine. The x value, what's the x value here at 0 degrees? 1. What's 1 over 1? 1. Tangent is sine over cosine. Y over x. Y over x at 0 degrees is what? 0 over 1 is 0. Alright, so I'll graph it here. Here we're at 1, 0. Alright, now let's do pi over 6, 30 degrees. What is my x value at 30 degrees? Radical 3 over 2. So I have 1 over radical 3 over 2. Because secant is 1 over the cosine. So this becomes 2 over radical 3, doesn't it? So on a calculator, what is 2 over radical 3? One point? 1.2, okay. And then here we have y over x. So the y is 1/2, the x is this. So y over x, we get, the 2's cancel, 1 over radical 3. And you got to square this. What happens when I square it?
It's 1 over 3.
1 over 3. Or 0.3 would be. Alright, so at 1.2, sorry. At 1.2, which is about right here, I am at 0.3. No big deal so far. It doesn't show us anything. We only got 2 points. Pi over 4. This is 1 over radical 2 over 2. Or 2 over radical 2. What is 2 divided by radical 2? See how I'm flipping it over because it's the, put that, the secant identity. What is it?
1.4.
1.4?
Yeah.
2 over radical 2 is 1.4. Okay. Alright. Now the tangent is going to be the y value over the x value. Isn't that just 1? Isn't the tangent at 45 degrees 1? Radical 2 over 2 over radical 2 over 2. Okay? And then you square it, you get 1. So at 1.4, which is about right there, we are at 1. This is right. And then do it again, pi over 3. And you're supposed to go to pi over 2. So you got 2 left. Pi over 3. The x value is 1/2. So 1 over 1/2 is 2. And the y value, or excuse me, the tangent, what do you have? The tangent is the y value, radical 3 over 2, over the x value, 1/2. That's just radical 3. And you got to square that, you get 3. So at 2, we are at 3. Look at what's happening. And then you got to figure out what the pi over 2 is. I'm going to let you realize what that is so you can figure it out. Now let's do part B before the bell rings. You just said, this is really simple, some of these are easier to get than others. You told me that the tangent squared of t plus 1 equals the secant squared of t, didn't you?
Yeah.
Okay. What's the tangent squared of t?
Y.
So I have y plus 1. What's the secant squared of t?
X. No. 2x squared?
X squared. Done.
Whoa.
Some of them are easy, some of them aren't that simple. Again, it's not possible to show you every combination. It's just, you'll be here forever. Okay, you're just going to have to, trust me, use your Pythagorean identities, try to work it out. Double angle formula is a possibility on some of these. Make sure you have your reference sheet. Okay, so your assignment for the first half of this section is page 569. You're going to do 3 to 23 odds,
Good afternoon, Western High School. Hope you had a
not
fantastic Monday.
21.
A couple quick reminders.
Good.
First of all, juniors and seniors, don't forget to check your